So we're just starting Unit 6 on geometric relationships. And what we start out with is a bit of review, some things that you should already know. So for example, just looking at triangles, one thing that I think you should already know is that the angles of triangles add up to 180 degrees. A scalene triangle, none of the sides are equal to each other. The sides are all different lengths and none of the angles are equal. An isosceles triangle, two sides are equal, so these two sides would be equal, and what that would mean is that the angles at the bottom of those sides would also be equal. So if this side's 30 degrees, this side's 30 degrees. Equilateral triangle, all three angles are equal and all three side lengths are equal. What that means is if the triangle adds up to 180, if we take 180 and divide it by 3, we get 60. So these angles are actually set. In an equilateral triangle, each angle has to be 60 degrees because they all have to be the same and they have to add up to 180 degrees. Something else that you've heard of but maybe have forgotten, an acute triangle. The three angles are all less than 90 degrees. This will come up again in grade 10 math. You will look at acute and obtuse triangles and that will be mentioned, so it's just good to review it. A right triangle, there's always one angle then that is 90 degrees. You know that we have a hypotenuse that is across from the right angle. That right angle usually should be marked with a little square in the corner to show you that that's 90 degrees. And then an obtuse triangle, one of the angles of an obtuse triangle is over 90 degrees. So between 90 and 180 degrees, that one angle in the corner. So I am going to get you to do some of these questions. Classify each triangle. Are these isosceles, scalene, equilateral? And same here, classify each triangle in two ways. So if we're looking at, is it one of these, is it scalene, isosceles, or equilateral? And also, is it acute, right, or obtuse? So this one, classify in two ways for that question. And then polygons. So this is going to be a big part of this short little unit as well. Polygons are closed figures. So polygons, for example, triangle has 3 sides, a quadrilateral has 4 sides, a pentagon has 5, and a hexagon has 6, which I'm sure that you know. Some special types of quadrilaterals down here, you can have a square, and this is also important in grade 10 math. You have a square where every angle is 90 degrees and every side length is the same. A rhombus is like a square that somebody kind of shoved over, so all of the side lengths are actually the same length. Obviously, we don't have 90-degree corners here, though. They are not 90 degrees. It's kind of a square on a slant. The same thing with a rectangle. So these are related, a square and a rhombus. A rectangle and a parallelogram are also related. So a rectangle, all the corners are 90 degrees, but the opposite sides are going to be the same length. A parallelogram, same thing. Opposite sides are the same length. But a parallelogram is like a rectangle that somebody shoved sideways. And then a trapezoid, opposite sides being parallel, but then the other two sides are not. So here, number 3, I'm going to get you to do, classify each polygon according to its number of sides. So read carefully the number of sides. Is it a triangle, a pentagon, and whether it's regular or irregular. So regular polygons mean that every angle is the same and every side length is the same. So if we think about regular polygons, just to go over that again, here is a regular triangle. That's a regular polygon. All the angles are the same and all the side lengths are the same. These two are also triangles, but they're not called regular polygons. When you're talking about 4-sided figures, out of all of these choices, here is our regular polygon. A regular polygon, every angle is the same and every side length is the same. And then classify each quadrilateral, give reasons for your answer. So just naming what these quadrilaterals are based on the information that you see there. Angle properties, this is really important. What the textbook does is we're just assuming that you already know this when we look at angle properties. So for example, opposite angles are equal. If you see two lines that make an X, know that this angle is the same measurement as that one. So if this was 110, this is 110. As well, these two angles would also be, the two B's would also be the same measurement. There's another angle property on here that I think you should really know. I want you to remember what supplementary angles are. Supplementary angles, that's when you would have a straight line, and so that would be 180 degrees. That would be a straight angle. And then if I have an angle measurement coming in, and let's say this side is 60 degrees, what I know about supplementary angles is that they add to 180 degrees. So if this side's 60, this side over here has to be 120 because together they have to add up to 180. This is a really useful property that you might use over and over again. So for example, if I knew A was 110 here, then I can find B because there's a straight line. So together, those two angles make 180, so B would have to be 70 degrees. So supplementary angles, remembering that a straight line is 180 degrees, will be really helpful. And then, yeah, the sum of the interior angles of a triangle, they all add up to 180. That helps when you're trying to find missing angles. And then this I'm hoping you've seen before, maybe in grade 7 or 8. Alternate angles are the same measurement. So this angle here is the same as this angle here. And what you see is a Z. So these properties occur when we have parallel lines. So if I see parallel lines, which are marked with these little arrows, then I see this Z that I can imagine drawing in there. That's the property of alternate angles, and that means that they're actually the same measurement. So this up here, if that was 75 degrees, this down here is 75 degrees. Corresponding angles, you'd see an F, and they are also equal. So the F could be upside down or in different orientations, but here, if that is 120, down here is 120. Those are the same size. You might see the F upside down. So for example, it could be drawn like that, and then those angles would be the same measurement. So that's called corresponding angles. And then co-interior is a little bit different. They are not equal, but if you see a C shape, these two angles in here add to 180. So if this one was 100 degrees, this one down here would have to be 80 degrees because together they would add to 180. So the other two, we're talking about equal. Corresponding angles are equal. Alternate angles are equal. But co-interior angles, when they make a C, there'd be another one on the other side here. These two angles in here are not the same. Maybe we'd use different letters or different symbols. Those two angles are not the same, but together they add up to 180. So I'm hoping everything I just said is a review for you. What I want you to do is questions 1 to 6 on this page, which I have attached, and then I have another page of review as well. So find the measure of the third angle in each triangle. This question, you'd want to find those angles. Remember that when you see that, that means it's 90 degrees. And then we're going to use some of those properties. So for example, you might see some alternate angles like that. You might see some corresponding angles like this. That might help. And you might also see some opposite angles. So when you have this X shape, then that helps you find angle A. We're trying to look for these properties that will help us find the angles without having to do much work. I see some corresponding angles here. I see some opposite angles. I also see a co-interior that is the C shape inside. And then I've attached another sheet, this more practice. And I want you to look for parallel lines. I want you to look for corresponding angles, alternate angles, opposite angles, co-interior angles. I want you just to find the missing letter measurements here that are marked underneath. So if it helps, sometimes it does, you can trace out some of these shapes, and then you know some of the answers just by looking. You also might see some triangles that add up to 180, so you're able to find some missing measurements. So give this sheet a try as well, and see if you can fill in these missing measures.